You can welcome back. So see what we are saying here. So third bit planes, what we can see here, the bit planes, so third bit plane extraction. So first we need to know that how many bits are required. So for example, the 24 level is there. So at least it requires the 5 bit. So 5 bits means you can represent it basically 20 basically by this one. This is this, how you will represent 20. This is 0. Sorry, this is 1, 2, 4, 8, 16. 16 and 4 it is 20. Is it clear? This way we are writing 24. This way we are writing 15. This way we are writing 2. What about the third bit plane? Right? Third bit plane, see, whenever we calculated third bit, so from where we calculated? We calculated basically it is 0, 1, 2, 3. 0, 1, 2, 3. That's why it is a 1, 1, 1, 1. So this is basically the third bit plane. So 0, this is 1, this is 2, this is 3. Right? That's why we are able to write it the third bit plane. Can you tell me which bit plane will be the best one to see the image? See the approximate image like the original image. See, are you able to recall bit plane slicing? I just go to. Are you able to recall, see, bit plane topic? See, this is 1110, what you are. See, what I want to emphasize, let me show you. Third words. Yeah, see this one. This is basically a bit plane slicing. Here, see, we created the bit plane image. Are you able to see? This is the one. This is the one bit plane slicing. Yes, right. Here we see use image basically, and here we basically took the binary representation of an input image. Bit plane extraction. So we created the bit plane images. So we created a binary value here and this one, and see, remember this 0, this 0, this 1, and this 0, and this 1. Where we have calculated 0, 0, this is 1, 0, and this is 1. That's how we have calculated it, right? This is the, in this way, this is the 0, 1 second bit plane. This is a 0th bit plane, the first bit plane, this is the second bit plane. Right? Are you able to get it? So what we are doing, are we creating planes? The planes basically means the two-dimensional. So 3-bit planes means basically when we are taking single bit. Why somebody is doing it? Somebody is doing it because when you take the single bit also, we are able to see the approximate image. In the same way, this problem also it has been shown here. But it has given the one more condition that you have to generate a binary image by applying thresholding at 15. What do you mean by thresholding at 15? Thresholding at 15 means basically you will take the threshold value, so that value, above value are 1 and other value are 0. So this way also you can generate it directly. This relation is given. This is given. Even including 15 is equal to 1. Can we move further or any question in this part? Are you with me? People, is it clear? Any difficulties, please acknowledge me where we are quickly going through the question. Aditya, it is yes. Is this B part clear? Image threshold. So what we are saying, generate a binary image by applying the thresholding at 15 and write the image, right? Can we move further? So this is another problem, which basically find the bit plane for given 3 by 3 image, right? This is the one. So definitely, so what will be the, how many number of bits will be there to represent it? Three bits, absolutely. How to calculate three? Okay, see, definitely see threshold. Okay, so then just a minute. See, threshold actually it was given here. We did not calculate it. It was given that threshold value is given. So threshold value means if something is above or equal to the threshold, then it means it is. See the question clearly. It has been showed that generate a binary image. Binary means either it is 1 or the 0 by applying the thresholding at 15. Thresholding at 15, so it is already given. We are not calculating the threshold. We are only calculating the other values with the help of the threshold. So above value threshold, so it is this one. Does it explain your query, Saujanya? Now see, find the bit planes are given this 3 by 3 image. So here see what we are seeing. Bit planes, so how you will find out, again see as pointed out correctly, 3 bits are there. So how we can write it? See, we can write it here. What we can write here, one is basically 0, 0, 1. This is 0, 1, 0. This is 1, 1. Sorry, 1, 0, 1. One zero one. So this way we can write all the values. So bit place lighting image into bit place or the basic contribution of each bit in the image. To find the bit plane, so every bit we have to taken out. So what will be the one? So we will take out. So first we need to fulfill it. What will be this value? This is 1, 0, 0. Here it is 1, 1. Actually, here it's a problem. Here it is 0, 0, 0. Here it is 0, 0, 1. Here it is 0, 1, 0. And here it is all basically the 1, 1, 1. That way we can write out and we can divide the image in bit planes. So that has been asked here. So that has been done it here. See 0, 0, 1, 0, 1, 0. And it's MSB middle and LS. Is it clear? Are you? Okay, fine. You have a 4 by 5 image below. This is a bit different example where rows and columns are not equal, but it is not necessary. Perform gray level slicing with respect to given function. Clearly mention new pixel values in 4 by 4 by matrix also represent the function graphically. So what is given here? S equal to 15. If R will lie between 5 to 10 and other values, it is R that you have to do. What do you use the gray level slicing? Are you recall what was the gray level slicing? See, we particularly focus upon some part. There was a clearly a linear straight line with 45-degree angle, but it was basically a sharp edge in between. Diagram. See, this is the one. This is the one intensity level slicing. See, this is S equal to K, R1 into R into this one. Are you able to see? Intensity level or the gray level. It is the same thing. So, are you able to recall? See, this changes there. This one changes there. This is the problem. So this is basically here it is given, and so in output image, so between 5 to 10 including it is 5, 5. It is 6 is basically 15. So even actually 5 is not included. Basically 6 to 10. So 6 to 10, here it will come 15 and here it will come 15. So this one view may calculate. This way it has been shown here. So when you will see the curve, for example, you begin to do the gray level slicing as per this one, so you would able to get this. Another the problem. The digital image is given of size m by n as basically 8 gray levels with the following normalized histogram. The desired target image as the following normalized histogram. Two images are given with the normalized histogram. Find the histogram matching. We've already done the problem upon the histogram matching. You need to basically calculate the PDF, CDF, and the new labels and the new N of K. What will be the new N of K? New N of K will be because many values will map to the same gray level and then it will add up, right? This is the case here. But one change is there. What is the change here? That when you will calculate it, you are given basically PDF, but what is missing? You can see it is there. Probability, this is there. We go to a desired target histogram, it is there. So we calculate basically the CDF of it. First image, then you calculate the CDF. Calculate this CDF of the desired image. Total pixels, yes, see, even see what we are going liquid through it. So SRK input is given. So it is, see, at this one is given. CDF of desired image, this is given. In second case, it is given. So this S is given here, this capital S is given, this closest ZZK is given. So this is 0.05. So this is basically 0.10, this is 0.30, this is 0.35, nearly the value, this is 0.5, so 0.7, 0.65. So what we are doing? So first we are basically matching the basically the closest value, and thereafter it is closest value. Then we are assigning that value. For example, 0, 1, 2, 3. This is 4, 5, 6, 7. So this way you have calculated. So final histogram matching information is this. So in the same way, this another problem is given. So here number of pixels is given. So remember, it really doesn't matter that if the number of pixel was given. So what you can do, you can calculate basically the P of R you can calculate. When you calculate the P of R, so it will not be a difficult one. So what you need to do? You need to do basically the normalize that thing with the total number of pixels. So this is here, this is CDF is shown here. So this is histogram matching closure ZK. Final gray level, it is shown here 0 to 1. So now coming to the part C, basically filtered part and convolutions is that part we have checked out. So in convolutions, till now we have in convolution, what do we take care that we take the image, we flip it horizontally, we flip it vertically, and then we are able to do the correlation. So how you are going to do here? This is basically 3 by 3 mask is there. So, and this is 5 by 5 maze is there. And so how you will do it? So when you will do it basically with this part, so you will need to do the padding also. W here, so when it has been shown here, how you will calculate the value at 50th value, at pixel value 50. If you calculate 30 into 0 plus 40 into 1 by 6 plus 50 into 0 plus 40 into 1 by 6 plus 50 into 1 by 3 plus 80 into 1 by 6 plus 35 into 0 plus 255 into 1 by 6 plus 17 0, and then this is when you will calculate it is basically the 86. And at the pixel value 80, again you can calculate the value, and then this when you calculate the value, you are able to calculate these values. So another image, see again, see what is now what we are doing here, what basically we are doing the convolution. The important thing in So assuming zero padding, you don't need to do the padding. So what you need to do, you need to do one thing here, that this central element, see, whenever you are doing the operation, that need to be coincide with that one. If it is not coinciding, then see either because since zero padding is not allowed, so you can no, it is padding is there. What is the way? So given kernel is there, so kernel. So what we are saying here, the kernel is basically flipped horizontally and vertically. So when you will basically flip it horizontally, then it is shown here. When it is vertically, it is shown here. So what do you mean by this 3 by 3 neighborhood around pixel 3? If we will calculate it, so what will we get? When we will calculate it, it is 2, 3, 1. Yes, we are calculating over this entire. So how you will basically perform? So here it has been shown here. So multiply element wise with the flipped kernel and so. So what is this value? See here you will directly multiply. See this minus 1 into 2 plus 0 into 3 plus 1 into 1. So what we are saying here, see this one here, horizontally, so minus 1, 0, 1. It has been shown here minus 1, 0, 1 here. When you have been going across with this. So this is basically the final 5 by 5 unfolding. Again, see the another problem is given that the following 4 by 4 grayscale image is given and 3 by 3 smoothing kernel H is equal to 1 by 9. Assuming replication padding is used. So here what I will now basically you perform the convolution of image 1 with kernel H. What is basically this kernel H? Kernel H is basically the filter. What are you going to do here? See, again, you have taken basically the image and then you have taken the filter. Which filter you have taken? Basically, we have taken the average filter. What you will do, no, need to do, say, again, see, when it is basically 1, 1, this multiplication is there. So we will get the other value. What are we going to do? It is, so when we were multiplying it, what we are doing here, so 1 is basically first moved to here. 1 will be in the center and so 1 will be in the center. So how many ways? 1, 2, 3, 4. It is 1, 2, 3, 4. So this will be we calculate in the application padding. Border values are applicated outward. The padded image basically becomes 6 by 6 and so we will get this. So yes, even when we will go through in the last one, so the average extra say bit will be added and that's why will have been generated. So regarding the convolution rule, as it has been shown, it is basically two-dimensional operations. Not we are going into the detail, it is complete mathematics. So sample calculation, it is 3 by 3. Neighborhood is given, and after 3 by 3 neighborhood, it is output is given basically given on 30 by 9. So final the convolved image. So how will you find out the convolved image here? See, when you will find out the convolved image, see, so what is this thing? 3.33. Again, see, so convolution, whenever you are saying it is convolution, you need basically the another thing that is basically the mass. So what we are showing the grayscale image and the following 3 by 3 convolution kernel that is given and assuming circular padding is used. So perform convolution of the image with kernel length. So that we want to do. How will we do it? So this is image is given here. This kernel is given. The kernel is symmetric. If you notice it, so flipping doesn't change it circularly. Padded image is there. Flipping does not change. Circular padded image is there. So okay. Circular neighborhood of pixel 1 by 1. it's come there. You apply the kernel, and then you in this way you calculate the G11, and then you calculate the other values of the G, and in this way the work is done. So another operation apart from the C convolution, it is basically the correlation. So in the correlation, see what you are doing, it is basically image I with mask M. So are you able to remember? See what did we do in the correlation? Correlation, see if you recall, see there is no flipping and directly multiply it in this way. Right. So what we are going to do, this I is given, this mask M is given, so padding is used, zero padding is process ribbing है. Sliding a mask over an image and computing the sum of element wise multiplication without flipping them. So here it is there, application of image correlation, it is edge detection, it is template matching, and it is feature detection, it is motion estimation. This is when we correlations, there is no flipping here. You will directly multiply here. So how you will multiply here? So this is a simple rule is there that this zero will be coincide with the one will be coincide with the pixel where we want to do this calculation. For example, if you want to do this zero with this two, then there will be one additional row will be created. Can we see it here? Yes, it is there. What will be the length? So 1 and 2, 3, 4, 5, 1 and 1 on the each side. So it will be the 5 actually. It has become 7 actually. 7 by 7. So this is the one 3 by 3 neighborhood around the pixel when we calculate it. So apply correlation, it is G3 of 3. So this is find correlated image 5 by 5. This is the question. Another question. Here it is the same thing. Circularly padded is there. So G11 means basically which element, what you are telling. So this is basically the 0. It is 0, 1. That should be the 0, 1. So it should be the 3. So what has been shown here, so this has been performed correlation. So this is the similar type of problem, and this for convolution operation, and this is final result and output signal. So this another problem there. What is the value of rounded pixel if it is a smoothed by 3 by 3 box filter? So what is the case here? So simple it is, see basically due to increase the problem, see how we are doing it. So we'll put the value in such a way that this one, see when you are basically saying rounded pixel, if it is smoothed by this one, it means this is the here. So this is calculated mean filter, weight average filter. So again, see what you need to know. You need to know basically the matrix, mask matrix. What was basically in the case of the mean filter? Mean filter, it is. So what is this value? This value we can take it. Either you can take it this value as 1 and here outside you can take it this value as a 9. So this is shown here. This is mean filter has been shown here, and this way you can calculate the value. Again, it is coming basically the point value, so you will round off to the that value. So given below is basically 3 by 3 image. What will the value of center level when this image is passed through arithmetic mean filter, geometric mean filter, harmonic mean filter, maximum filter. So how will you calculate it? It's an open problem. Can you find out it? Just have a thought over it. Any answers? How arithmetic mean filter? See, actually we are already doing with arithmetic mean filter. Geometry. So see, I show you. See, arithmetic mean filter. See, exactly we are doing it. That was the arithmetic mean filter. It's 31 by 9. What about the geometric mean? Geometry means see, if you take it all these values, then it will be 1 by 9. If you remember it, under root it is 1 upon this value. Are you able to see? See, these are basically all the 9 values. 5, 1, 7, 6, 2, 3, 4, 2, 1, 5, 1, 7, 6, 2. What about the harmonic mean filter? Harmonic mean filter 9 upon this value, and so you will able to get this value. Maximum filter value, minimum filter value. This is so yes, see, this is basically the arithmetic mean filter. Geometry and basically it is the reciprocal, it is there. So you are able to calculate this way. What about the max filter and min filter? Are you able to understand? See, max filter basically you are taking the maximum value here. And minimum filter, this is minimum value. Absolutely, maximum value in the neighborhood. Perfect. So now coming to the this question number, this one. So this is an image here and case B and kernel perform convolution and correlation. So again, see here mathematical aspect is there. So actually see these functions today in Python and MATLAB you can directly execute it. See, but once you are able to do the calculation, it gives you lot of confidence and you are able to know the range of the calculation that what would be the estimate, etc. So we see that things in convolution, the important thing it is you rotate the kernel by 180 degrees. To rotate the kernel, it is basically 1, 2, 3, 4. You rotate it. It is, see, first what you are doing, I tell you. You basically rotate it vertically as well as horizontally. So check out. This is the one, this is one, this is two, this is three. Once you will rotate it basically horizontally, you can do either of the way. First you can do, what will you get? So you have done basically the horizontally and then you can do the vertically also. Sorry, this is basically this is horizontally and when you will do it vertically, so what you will get here, this is 4, 3, this is 2, this is 1. So this is the one. So this is rotate the kernel by this thing. I think, is this clear? And now you need to multiply it. This is the convolution, and when you will multiply it, so how will you do the multiplication? You have to put this value of the 4. See, you have to put this value of the 4 here. 4 with the 3. So 4 with the 3, 3 will with the 3, and the other value also it will calculate. So it has been shown here. So this is 4, 3, 2, 1. See, you can see here. So are you able to understand this value? Getting it? This operation? See, first I tell you, see what will you get? So first operation when you are doing it, see this is the first one. Last value should be the, see, once we have calculated this one, so you see here 4 will come, here 3 will come, here 2 will come, and here 1 will come, right? So 1 into 3 equal to 3. Now you will shift toward the right. So it will be 4 here, 3 here, 2 here, and 1 here. So what you will, when you do it here, so you will get basically what value? 3 to 2, 6 and 1 into 3. This is basically the 9 value. So is this clear? When we are moving it here, it is 4, 3, 2, 1 here. So this is you are calculated the value 9. So in this way, you can calculate the other value. When you will shift it toward this one, you will calculate the 3960, and so this is the one. And so in this way, we will calculate all the values and finally see when you are able to calculate. So this will be this way the one. Actually, it's a bit mathematically a bit larger, this computation, but this is the one. 396, it is 1230, this is 138, 921, 12, it is 0, 0. For correlations, you don't need to flip it, you have to directly take it and then you will calculate. Now consider this image below and calculate this output of the pixel if smoothing is done using 3 by 3 neighborhood using all the filters below. So what it has been shown here, the mean filter. So consider the image below and calculate the output of the pixel if smoothing is done using 3 by 3 neighborhood using all the filters below. So what it has been saying here. Again, see, to necessarily a low pass filter you need to use. So mask is there of 3 by 3 size and then you need to apply it here. So what would be the one calculate the output of the pixel 2 by 2. So in box filter it is there. So what we are showing 1 by 9. So it is box 1 here, 7 by 9. It is 1 by 9. You have done it. Weighted average filter. Weighted average filter. See what weight you are taking. So it is basically 1 upon 17. It is this value is given. So this way you are taking the weight. See, it is up to us if you recall. Are you able to recall the weighted average filter concept? Yes or no? Are you? See, we discussed it. Everything we discussed it yesterday. See, this was basically the weighted average filter. See this one. Are you able to recall? Yes, it is. So what is the important thing here? The only simple thing that it is, which are basically the 4-point neighborhood, it is giving the more weight and which are at the diagonal element, they are giving the normal weight. At central, it is giving the maximum weight. And so when we will add up all these values, they will add up to the value 60. See, 4, then this is 8, 12, 1 plus 1, it is 4, it is 60. Same thing it has been shown. The same thing we have done here. 1 to 1, 2, 4 to 1. So that we have done exactly. And when you take it, when you will round off, it will be equal to 5. But what is important to see is that even when you are using the box filter and when you are using the weighted average filter, you are getting the same value here. So are you able to recall median filter? Can you tell me whether median filter is the linear filter or non-linear filter? Are you able to recall? See, we basically describe two type of filter, linear, non-linear. Median is basically one of the classical filter which really solve the problem. If you see in the median filter, see we plot out all the values, whatever these values are there. See this 0. So how will you do it? See what do we do? So which value will be the, so how many values should be there? These should be the 9 values. 1, 2, 3, 4, 5, 6. This is 4 and yes, this is 5. So which one is the middle value? This is the one. This 5 is the median. So absolutely. So 5 is the answer. Minimum filter, this is minimum value, this maximum filter, so this is the one. So this is the why median filters is very, very important question. Those people who are trying, means when they give interview, this is very important thing. As I just discussed it, that it is very much better than the mean filter. So basically it has a two advantages, that it has a more robust average standard question, and so a single unrepresentative pixel will not affect the median value significantly. See, for example, see in the average, etc. For example, some value can be very much higher. Some noise may be there. For example, when we are taking the mean value, to, for example, while noise and one value can be, for example, uh, in the last example, for example, here 1/9. By, for example, if some value is 50, then this mean will come very higher. It may be a noise also. But if it is a mean, if it's a median, it will not allow to affect it. This is the one point. Suppose the values are even, then how to calculate the median? See, then basically what do? You actually see, if you remember, we always take out the this. Uh, if you recall, we take out only the odd case of the mask. Actually, it depends upon the mask. Even we can calculate the median, so whatever the values are there, we can take the average of them. But to avoid that problem, we take out always the mask 3/3, 5/5, 7/7, etc. So what, and another thing, yes, it is always odd. That's why we can take the this way. And even see one of the another reason, that on the pixel where you want to fixate upon, where you want to center it upon. So it should be, its neighborhood should be symmetric. Its neighborhood should be symmetric. So that's why also we take. Since the median value must actually be the value of one of the pixels in the neighborhood, the median filter does not create new unrealistic pixel values when the filter straddles an edge. Therefore, it is much better at preserving sharp edges than the mean filter. So see, this is again, see, as I told you, one of the things that we must be very clear, see what is happening at the image level. What is happening at the image level, we are much more interested in. It actually preserves the sharp edges than the mean filter. In mean filter, actually it is blurred out. But here, whatever the sharp edges are there, that will remain. Mean filter is better at dealing with Gaussian noise, etc. Better at dealing with salt and pepper noise. So this is telling some example. So this is basically an example when you are taking basically the salt noise is given. So what do you mean by the salt noise? Salt noise means basically salt and pepper means salt is basically the white value, pepper is basically the black value. So these values are given, and in between, if you take it, so it is able to correct out the correct figure. Another, see, write down a few approaches to deal with the missing edge pixel. See, this is also the problem. Not only see we do the image enhancement, but also we use it to find out the missed edge pixels values. What do we do? So we omit basically missing pixels. So only works with some filter can add extra code and slow down processing. So that is actually the result of missing edge pixels. Pad the image. What you can typically with either you pad it with all the white values or the black values. That also you can do. You replicate the border pixels. Why? Because we know that the image holds in the continuity. Truncate the image, allow pixels wrap around the image, can cause some strain. So this is another. So for example, the input is given. So this is basically mask is given, and thereafter mask it has been shown here. This operation, this input image, this is zero padding, pixel replication, wrapping of pixels, and what it has been showing. So So zero padding, what do you mean by the zero padding means? Zero padding means you add up the zero. What do you mean by the pixel replication? See, for example, when pixels are missing here. So for example, when this mask is there, you can write in this way 1477789. In this way, you can write the values here. Here also you are writing one. Here also you are writing one. Wrapping of pixels. Wrapping of pixels means basically see 1, 2, 3, 8, 9. So what we are going to do here? Here we are basically flipping wrap. So what is here? 1, 2, 3 is basically coming here. 7, 8, 9 is coming here. So 7, 1, 4 is coming here. 9, 3, 6 is coming here. So this is how the missing pixels are also provided. What do you mean by see? Even see if you when we multiply the mask, when you multiply the mask with the other values of your image, then also we need to provide the values. So normally we take the zero padding, but if somebody, these are also the other ways that pixels application can be there and pixels can be wrapped out. This is any question. So see, today we have very quickly covered the many questions, almost 73. So today we have covered almost 36 questions very quickly in a go because see, we had been clear about the concepts and today we want to go over through the things very quickly. Yesterday we had been emphasizing upon the concept that how we can build up the concept. If once the concept is built, then you can very easily don't find any difficulty in doing that. So I think it may be a bit exhaustive to you, but yes, uh, no problem. We are going to conclude it within next 5 minutes, 5 to 10 minutes. Any question if you have? So are you? Can we take for 5 minutes? Then we will conclude it, right? I think. Are you with me? Or I am alone only here. Tomorrow, yes, tomorrow for session 10. See, it is actually 10:30. We have put it. So you will see we can. So going through the just 1, 2 problems, then we will take up the problems in the last tomorrow. Just take your time. This is the if you have any questions, but before it, if you have any more questions. So how are you finding? What you are finding? Anything new here? Anything repeated here? Anything? Whatever your observation, keen to hear to that. So first we do it. First we do 2, 3 problems. Then we will conclude it so that you will also be feel free. Otherwise, you will. So see, just 1, 2 problems that I need to show you. Basically, uh, 6 repeated so many times. Yes, 6 is repeated, and so what is this thing? See, if you will take it here, what is one thing is clear that 6 is there, so it will be 0. So in between first order derivative, so 6 minus 6 it is 0, 0, 0 minus 1, 4 minus 5 minus 1, 3 minus 4. And we see it. It is fx plus 1. So this is there. Exactly. See, whenever you are dealing with any problem, you need to know the structure which you need to prepare to solve it. So this is the structure I need to prepare it. What structure? Structure is basically this. So this is the structure you need to prepare it. This table. So delta upon del x, this is 6 on 6, it is 0. This is 6 is 0. This is 6. This is 0. But here 5 minus 6. Remember this value, which value is coming? 5 minus 6, this is minus 1. 4 minus 5, it is minus 1. This is here 6 minus 6, it is 0. Here no more value there, so that's why it is crossed. In the same way, what we will do, we will use this value. This is minus the fx plus 1, fx minus 1, minus 2 fx. So what we are going to do here, so even see minus 1, even what we can do, even see in the double derivative, even see at this level, it is minus 1, minus 0, it see minus 1, 0, it is, so see what we are doing here. See, so it has been shown the location fx minus 1 is this one, fx is this one, and fx plus is this one. So when you are calculating, see this one, so you need the behind value, next value, and this value. So what is this one? We calculate for this one, 6, right? So its behind value is 6, its after value is 6, and 6 plus 6 minus 2 into 6, it is 0. We come to this part, middle value is 6, behind value is 6, afterwards value afterward value it is 5. So 6 plus 5 minus 2 into 6, 11 minus 12. So that's why it is minus 1. Is it understood? In the first case, you need the next value. Here you need the next value. This is the next value. Since 6 has doesn't any next value, so you can't able to get. So this is the way you are able to calculate, and this is the way you are able to. So this is the create an image. This is the final question. Consider an image shown in figure 5. Suppose we apply a 1 by 3 average filter on an image I6 to get the image I7. Again, we apply the same filter I7 to get the image I8. Find the final value of the center pixel. Consider an image shown in figure 5, alias I6. Suppose we apply a 1 by 3 average filter on get the image I7. Again, we apply. So this is I6. This is given 2, 5, 6, 7, 4. So this is given. We apply a 1 by 3 average filter. So 1 by 3 average filter, it is given this one. So to get the image I7, what is it saying? That you apply this filter on every pixel. So again, see, it will average out. How will it average out? See, you can see here. For example, this is three values, it will average out. Behind value and the next value. When you are taking this two values, इसके behind क्या था? It is 0. इसके next क्या था? It is 5. And this is 2. 2 into 1 upon 3. 5 में क्या है? Behind क्या है? 2. 2 into 1, 5. 2 plus 5 plus 6. 11, 13 upon 3. So this is 13 upon 3, and this way you are able to calculate. Again, so you need to round about it. It is 2, 4, 6, 6, 5. So this is again we apply the same filter I7 to get the image I8. So same filter I7, it means you are applying the average filter. So again you will average out and again you will do that thing. This is how you are able to calculate it. So here we conclude it. At which problem? The problem at question number 77. And consider it basically as a 7 by 7 filter, 7 by 7 mask. There we have concluded it today's session. Now, for any query, anything. Tomorrow we will basically take up these problems. In the morning, we will take image segmentation. That way we will basically able to cover the basics of the course. And then in the next week onward, we will basically focus upon the application. Thank you. So one thing more, so tomorrow actually quiz will be uploaded to you. So quiz C has been already uploaded, right?
Activated after 7 p.m.
So after 7:30 p.m. it will be activated. You can take your time. Oh, and from 17 onwards uploaded. Whatever course we have covered till now. And it there will be we have decided to not burden you with many things. So it's only one quiz plus that assignment. And you can submit it till Monday. Shouldn't be in hurry. You should enjoy the learning. That's our purpose. So 22nd December, when it is the longest night, right? Shortest day, coincidentally. There you need to submit it in the noon. Night, I think you leave you. This is the time. So in the noon, 11:59 a.m. I write it. Right. Okay.
Different options.
So again, see, to without any ambiguity, it is still basically the night. See. But I suggest you that you do it in the daytime only, so that you may enjoy the good sleep, because our lecture is also there on the next day. I hope you would have enjoyed both the conceptual as well as problem part. Okay, thank you, Shruti. Thank you, Saujanya. Thank you, Rajesh. So if you don't have anything, so we will meet up at 10:30 a.m. tomorrow. Thank you. Have a good day.